Hello. So we will discuss about the heap sort operation, remaining heap sort operation, which was in previous lectures. We discussed about only the insertion operation, that is how to insert a node into a heap. But now I am going to describe the two more operations we want to implement, which is the deletion of root node from the heap and replacement of root node of the heap by some new value. So in case of first we will discuss about the replacement of the root node by some new node. So now when we replacing or we are changing a heap, so either by insertion of a new node or by replacement of a new node or by deletion of the root node, the heap structure again will be lost. So after doing any operation, we have to make sure that after that operation, that also becomes a heap. Before operation, it was a heap, and after operation also, it should be a heap. So now, in case of case in 3, we have some movement only upwards or downwards. Only this two movement is possible. Now, in replacement operation, it's supposed to not have value 90, and we want to replace this value by some other. Suppose we want to replace it by 50. So what we will do, we will replace the root node first, and at that index array position, I will place the new node which has replaced the root node. And after placing to that position, that is root position, after placing the new node, then we will check whether new node has any child or not. If it has any child, then it will be interchanged with its child, which if its value, the new node value is less than any of its children. Then if the children which has a higher value and which also is a higher value than the new node, so new node will be replaced with that children. So the child node will go to root position and the new node will come to child position. That means we are moving downwards of the heap. Now again, this new nodes after one time downwards movement, it will check whether the new node has its children or not. If it has any children, then it will check whether it has value less or greater than any of its children. If it has value less, the new node has your to its current position. If it has value less than any of its children, then this new node will be interchanged with that child. And so it will come downwards, one level downwards. In this way, we have to continue the downwards movement until we reaches at the last level. Or then or another stopping condition for downward movement is that in the current position where the new node is, if it has value greater than all of its children, then there is no point of downward movement, and in that case we will stop considering the downwards movement. So repeatedly, either we have to check whether it will go to next level or not. If it goes to next level, then again that downward movement will be done with the considering that next level and considering the next level of that new position of that new level. So to implement this, even we will write a function for delete. Suppose delete is a function, replace is a function. Then we will check whether we will allow instantly enter my which new value I want to replace a root node. And when this value is entered, that will be placed in the root position. Then we will implement a function which is move down, so that we can check whether the downward movement will be valid or not. If downward movement will be is valid, then it will be the downward movement, and there is also the stopping criteria, how long this downward movement will go on. If the new node has value greater than of all of its chosen, then we will stop the further downward movement. Otherwise, if it goes on continue, then until it reaches at the last level of the node, the downward movements will be continued. So we will implement this. So we will implement this in the code in the next lecture.